Welcome to this unit. My name is Samantha Caputo and I will guide you through this unit of the course. I am a member of the TICAS staff working in the Bioplastics Europe project. TICAS is a non-profit consortium established in Genoa in 2010. Our mission as a meeting point between research and industry is to stimulate the local system of innovation in the fields of environment, bioeconomy, energy, hydrogen and materials. In the last unit we talked about biodegradation processes. Now we are going to present commonly used techniques to evaluate biodegradability of a material and the corresponding standards. There are several processes associated with biodegradation, and diverse methodologies have been designed to monitor decomposition development. The picture shows the main techniques used to measure biodegradability. In particular, biogas production or oxygen consumption indicate a microbial mineralization activity and should be elected as the optimal biodegradation index. Let's see each one in detail. This integration is the percentage of mass loss with respect of the initial mass, as represented by the specific equation. Mass loss of samples determined during the testing period is considered as an index of biodegradation. In fact, it is well known that biodegradation is initiated from the outside surface to the inside of a material. For this reason, erosion and perforation increase the speed of degradation because the holes formed accelerate the diffusion of diverse substances and enzymes into the biopolymers. In an aerobic environment, biodegradability is usually determined by measuring oxygen demand in a closed respirometer or the amount of carbon dioxide evolved over time. When oxygen is not available under anaerobic condition, biodegradability may be evaluated by measuring the released biogas, which is a mix of methane and carbon dioxide. Biodegradation takes place in a closed vessel called the bioreactor, which contains the sample exposed to environments as compost, soil, and marine water. The bioreactor is connected with a respirometer for determined respiration of microorganisms during biodegradation by analyzing gas evolved or consumed over a set period of time. A software allows monitoring of all parameters, simulating various testing conditions and recording data in continuous. Mechanical properties are physical properties that a material exhibit upon the application of forces such as compression and tension. The knowledge of mechanical properties such as hardness, softness, stiffness, and brittleness of a material contributes to highlight how a polymer can be used and its resistance under the environmental conditions of surface, such as air and water turbulence and snow pressure. Changes in mechanical properties are determined by comparing the amount of deformation permitted before and after exposure. One of the most common mechanical tests is a tensile test, which gives information about the behavior of the sample under tension load, depicting how strong a material is and also how much it can be stretched before it breaks. Other biodegradability indicators make use of spectroscopy or microscopy. Spectroscopy is the study of interaction between matter and electromagnetic radiation to investigate the molecular and structural composition of samples during degradation. Scanning electron microscopy allows the analysis of the sample surface. In particular, this method produces images that reveal information on its composition and morphology. Changes on the material surfaces during degradation include erosion, cracks, and fractures. As we saw until now, techniques to evaluate biodegradation in natural environments are several and diverse. Hence, it is necessary to provide a specific feature to ensure their consistency. Standardization and certification systems assign rules, procedures, and guidelines, namely standards, that a product must comply with before it can obtain certain label. This system allows to improve the suitability of a product for their intended purpose. The key standardization bodies creating standards are International Organization for Standardization, European Committee for Standardization, and American Society for Testing and Materials. Standards are intended also for product labeling, which allow identification of the product by consumers, enabling the proper end of life and assuring product quality. The main product labels associated with the biodegradable materials are summarized in the table and are related to the most common environments, which are compost, soil, and marine water. Most common techniques to assess biodegradability were presented. Selecting the most appropriate method for demonstrating biodegradability of a product can be critical because it depends on a lot of factors such as the material composition, target application, and receiving environments. Testing and certification schemes are useful to validate and contextualize statements of biodegradability and also to support labeling and user information efforts. In controlled environments, standardization involved in biodegradation can be easily achieved. Instead, natural environments are much more complex. Many factors contribute to an environment in which material may degrade. Hence, standards and certification systems need to be developed in order to include applications in which plastics are intentionally brought into the open environment and those in which loss is intrinsic in their own use. Thank you for your attention.